Have you ever pondered the mysteries of the universe and wondered what lies beyond the visible cosmos? Well, let's dive into one of the most mysterious celestial enigmas known to mankind: black holes. These cosmic behemoths are not just your regular celestial bodies. They are the remnants of massive stars that have collapsed under their own immense gravitational pull. Picture a celestial body so dense and so massive that nothing can escape its gravitational pull, not even the fastest thing in the universe, light itself. Yes, that's right. Light, traveling at a speed of about 186,000 miles per second, cannot escape the clutches of a black hole. This is what makes black holes invisible and incredibly intriguing. So what happens when something enters a black hole? Well, once it crosses the event horizon, there's no turning back. It's a one-way trip to the unknown. Imagine the strength of a force that can keep even light from escaping. That's the power of a black hole. Now picture yourself on the edge of a black hole. What do you encounter? The event horizon. The event horizon, in the simplest terms, is the point of no return around a black hole. It's like the ultimate boundary, the last frontier, where the gravitational pull of the black hole becomes so strong that nothing, absolutely nothing, not even light, can escape its grasp. This is why we call it a black hole, because all light and matter that crosses this boundary is swallowed up, never to be seen again. Now, you might be wondering, what happens to objects as they approach this boundary? Well, they undergo a fascinating, albeit fatal process called spaghettification. Yes, you heard that right. Spaghettification. It's a term coined by scientists to describe the way objects are distorted into long, thin shapes as they're pulled into a black hole. Black holes aren't just cosmic vacuums. They have some fascinating attributes. Let's dive into one of the most intriguing features of a black hole: time dilation. This is not a term straight out of a science fiction novel, but a real phenomenon. Time dilation near a black hole is a mind-bending concept that arises from Einstein's theory of relativity. It tells us that time doesn't tick at the same rate everywhere in the universe. In fact, the closer you are to a black hole, the slower time runs. This means that if you were to hover near the edge of a black hole, time would pass slower for you than for someone further away. So, in a sense, a black hole can be seen as a kind of time machine, albeit a one-way trip to the future. Now, let's turn our attention to a term that might sound equally daunting: the singularity. This is the point at the center of a black hole where, according to the theory of general relativity, gravity becomes infinitely strong, and space-time curvature becomes infinite. In other words, all the matter that has been sucked into the black hole is crushed into an infinitely small, infinitely dense point. This point is the singularity, a place where the known laws of physics cease to be useful. The singularity is hidden within the event horizon, the black hole's point of no return, and thus it remains a mystery to us. Black holes, with their time dilation and singularities, are still subjects of intense study and debate among physicists. They challenge our understanding of the universe and force us to think beyond the realms of ordinary physics. They aren't just about destruction or swallowing up stars and galaxies, but about creating the most extreme conditions in the universe. Conditions under which space and time behave in ways that we are just beginning to understand. You might be thinking, how do we know so much about something we can't even see? Well, let's dive into the fascinating world of black hole discovery and study. The study of black holes is not as straightforward as studying a physical object you can see and touch. Black holes, by their very nature, are invisible. They are regions of space-time where gravity is so strong that nothing, not even light, can escape. So how do scientists detect these elusive entities? The answer lies in the effects black holes have on their surroundings. Imagine a marble rolling around a funnel. The funnel represents the gravitational pull of a black hole, and the marble represents a star or gas caught in this pull. By observing the movements of stars and gases near where a black hole is suspected to be, scientists can infer its presence. In addition to this, scientists use advanced telescopes that can detect different types of light, such as X-rays and radio waves. Black holes often pull in nearby matter, forming what is known as an accretion disk. As the matter in this disk spirals into the black hole, It heats up and emits X-rays, which can be detected by these telescopes. But the icing on the cake came in 2019 when we got the first ever image of a black hole. This was possible thanks to the Event Horizon Telescope, a global network of synchronized radio observatories. This image didn't show the black hole itself, but rather its event horizon, the point beyond which nothing, not even light, can escape its gravitational pull. This image was a major breakthrough, providing visual evidence of something that until then was only known through indirect observation and mathematical models. So, even though black holes are invisible, they are not silent. They influence their surroundings, emit X-rays, and even cast shadows against the glow of their accretion disks. Even though they're invisible, black holes have a lot to say. We just need to know how to listen.